Hi everybody, welcome. So good morning, good afternoon or good evening, depending on where you are. Welcome to this IBPSA Education Webinar on urban scale building modelling. In this webinar, we're delighted to have Christoph Reinhart with us, who is going to be exploring ubem.io. This webinar is part of a whole series of webinars on urban building energy modelling. You can look at the previous ones on our YouTube channel, which I'll give you details about later. And it's part of IBPSA Education's purpose, which is about identifying the education and training needs in the community, developing new materials and new ways of meeting those needs, and importantly, our training and information is open to non-members as well as to members. So I would very much encourage you to get in touch if you think there are things that you would like to see coming up in future webinars. If there are needs you think we're not addressing, then do please let us know and we'll see what we can do. The best way to get in touch is usually via LinkedIn. So do please let us know. So the way that this webinar is going to work, I'm going to invite Christoph to give his presentation in a minute, and then please do put any questions that you have into the Q&A box, which you should see at the bottom of your screen. And then once Christoph has finished giving his presentation, I'll put those questions to him. And then after Christoph has finished, I'll give you a quick update on the future webinars and what's coming up. But for now, I'd just like to say thank you very much, Christoph. I'm going to stop sharing my screen. So if you would like to share your screen and start presenting.
Absolutely. Greetings, everybody. Thanks, Pamela, and thanks to IBPSA for inviting me to give this presentation. Let me see where we are. Hope everybody is doing well whenever you're watching this. If you have any questions beyond the seminar, I'm happy to answer it via email afterwards as well. So as Pamela said, I'm going to talk about urban scale building energy modeling, and I like the title that IBPSA gave me for this, Exploring the Power of ubem.io in Action. And I think focusing on the actual deployment of urban building energy modeling in practice to create value is really key. I'm giving you a little bit of an intro how to get actually to ubem.io. It's just a web app, so it's really just a URL. But I'm not going to give a software demo per se. But in case there are any questions, we have some video tutorials, and it should all be pretty clear how this works. Just a bit of an introduction or background. I am, here we go, from the Massachusetts Institute of Technology, where I direct a lab that's called the Sustainable Design Lab. And with members of the lab, we've developed a lot of urban building energy modeling and daylighting tools over the years. And at the same time, a lot of my work is in collaboration with the Harvard spin-off called Solemma, with whom we are developing daylighting and energy tools. So all of what I'm presenting, you will see always at the bottom right of the slides, the actual members of the lab who worked on this. So we take a step back, just a couple of minutes for background. I think it's key when you are about to develop your own building performance simulation software, or when you want to use one, to be incredibly clear about why you're using it, what the value proposition is, and who the users are. And of course, with ubem, we are tackling big societal questions, starting off really with this graph that shows you what countries in the world have pledged carbon neutralities. And if we look at it, it's kind of fantastic that we see most large economies in the world having said that by 2050 or 2100, they want to be carbon neutral. And this is, of course, a remarkable change in attitude towards energy. If we go back 70 years to 1951, the Paley Commission, that was basically when the United States at least formulated its approach to resources and energy, basically recommending to President Eisenhower that we should get the cheapest resources and energy that we can possibly get anywhere on Earth without any consideration of where these resources are coming from. That obviously backfired for us during the 1970s, during the oil crisis, but still this kind of attitude lingered that the prosperity of of an economy is linked to the gross domestic, so the gross domestic product per person is linked to the energy use per person. And it's really only very recently that we thought this can be decoupled. And now, as we see here, we even think we can reach carbon neutrality without giving us economic prosperity. So what are the drivers between these really unprecedented goals? I want to highlight them because I think when you use UVM, you have to talk to all these different groups. And the first one being, of course, attitudes in general, that a lot of, especially young people, but just society as a whole is really keen on us changing our way, how we treat the planet and the carbon emissions that we are emitting. Then, of course, when it comes to cities, it becomes, in some cases, just pure survival. If we look here at these images from Jakarta, which is the first mega city that basically indicated that they're going to leave their current location, then we just see how dramatic the changes that we are going to experience in our lifetime are likely going to be. And then, of course, when we are moving more into cities are getting hotter, so more frequent heat waves. We have a lot more people moving into cities. And finally, the new residents of cities have very diverging income levels. So with 1% of the global population owning half the world's assets, that means that these individuals that come into cities often don't have the same opportunities to design and build houses, have suitable living conditions. So if we kind of summarize the field of building performance simulations, or UBAM, then really we want to help address urban densification, inequality, while at the same time working towards a net zero building stock. So with the next couple of slides, I just want to frame the problem more, because there's often this talk, of course, about climate change and what we should do about it, but how that really relates to the building sector. And I think you need this kind of framework to even start talking to municipalities. So if we say that we want to keep global temperature rise under a long-term target, let's say the US government's official target is 2 degrees Celsius global temperature rise, then we know how much carbon as a budget we have left, 930 gigatons that we can use until 2050. And by that point, effectively, the global economy has to be carbon neutral. And if we then say, okay, 40% of that go to the building stock, then a really easy number to remember is we have 340 gigatons and 30 years left to make the global building stock carbon neutral. And then, of course, when you do an Uber, you should zoom in your local environment, how much of these buildings of today's building will still be there in 2050, and how much more buildings do we have? So depending on where you are, obviously, there's going to be a lot of new construction. And once you have those numbers, we made a very simple model as to see from a business as usual case what has to happen to reach carbon neutrality for the building stock. And effectively, there are 2 things to remember. Our goal for 2030 is we have to increase the annual retrofitting rate globally to 5% per year from currently 1%. So 5-fold increase on activity for retrofitting. And all new construction has to be carbon neutral, ideally including embodied energy by 2030. So this is the global background. If I'm now zooming into New England, then the question is always, wherever you do an UBAM, what technology pathways actually lead to your goals? And we've done a very careful kind of analysis for a typical New England home, what has to happen if an owner wants to live in the building and retrofit it and reach carbon neutrality. And the same type of work is, of course, to be done all over the world. So there are 2 kind of conflicting messages. Right now, if you're living in New England in a single family home or in an apartment, then basically the message is electrify your heating, so get a heat pump and get a PV system. And when we look at this on the left-hand side, we see right now, due to the cheap natural gas in New England, that increases your energy costs. It reaches nominally carbon neutrality. The problem is, of course, that the grid couldn't sustain that if every building would be rely seasonably on having photovoltaic on the rooftop in the summer. Where would the electricity in the winter come from? So really what we want to do is this kind of detailed analysis for each building where we say, what's our current baseline? How much money do we pay if we end up implementing these different types of upgrades or upgrade packages, then how do we reach lower carbon emissions overall by reducing the peak loads that the building stock has as well. So our goal is really to create graphs like this for every building everywhere. And for that, we're using urban building energy modeling. Just a reminder to everybody what method we are using. There are, of course, different ways to generate geometry. For the type of models that I'm going to focus on with UberMIO, we use a very simple extrusion process where we use the GIS file, extrude it up, and create then a multi-dimensional energy plus model of every building in the city. The first time we've done that, the technology from UberMIO is actually not very new. In 2016, we built this 80,000 building UberM of the city of Boston, and that was really our first engagement. Since then, we've done a lot more development, and obviously this is a global effort. A lot of groups are working on this. We've also started to kind of pinpoint what are the use cases. And when we started with urban building energy modeling, we really focused on this use case one, like new building, new city development, new neighborhoods, and looking at multifacets of urban performance, from daylighting to urban food production and so forth, including energy. And we've really now focused on this use case too that I'm going to talk about now, and that's also what UberMIO is about. So the context is here that a lot of cities have gone through various steps on their journey towards carbon neutrality.
Jing
A lot of
Feng,
cities,
I think we've lost.
Have a carbon inventory. So actually, we're looking here at Oshkosh, Wisconsin, which is a small town in the middle of America in Wisconsin. They knew in 2013 how many tons of carbon per year they're using. That their carbon reduction goal, which is typically motivated from what smaller communities see what larger cities are doing or what the federal government is doing, and then they don't know what to do next. And so really a key idea, which is also documented in the paper that you see here and some of the other papers, is that if we want to make urban building energy modeling more affordable globally to a lot of communities, we have to rely on existing knowledge rather than having like expert consultants or academics that have degrees in sustainable design, GIS, and in energy modeling. And the first component takes some policy making as well. We really want to tap into existing kind of knowledge in cities. So we identified the sustainability manager, who is more of a generalist, typically working for the city. That can be a citizen organization as well. Then the GIS manager. In very many cities in the world, there are GIS data sets available. And what we are needing here, footprints, building heights, building age, is easy to get in a lot of jurisdictions. And then finally, kind of our bread and butter community, the energy modelers. And so the outcome of UberMIO is something like this, where we basically say, okay, currently this is for the city of Oshkosh. This would be our baseline energy use or carbon emissions today. Then you work with the city, you develop what is a shallow upgrade for you, what is a deep energy retrofit, and then you see where they would end up. And then finally, if you implement some photovoltaics as well, how much do you reduce the carbon emissions? And then you effectively see that in this case, you would get close, but you wouldn't fully reach the 2050 target. And then kind of our next step is to then communicate that back to the citizens. So this was basically our sample poster that we did for Oshkosh at the time, where we basically said, okay, you want to typical energy retrofit or a deeper retrofit with heat pumps and solar and so forth. These are the costs, these are the carbon emissions. This is something that the city, your client, then can use and communicate back to their citizens. So after going through this process in Oshkosh, we basically wanted to do that with cities anywhere. And this is where the lab started to develop this UberMIO web app. We now have a joint development with Yu Tianang, who is a graduate from our lab and now professor at NUS in Singapore. And then we have collaborations with University College Dublin. We had that for building templates from Dublin. We worked with IST in Portugal and NTNU in Norway, always to basically be able to adopt our tool to local building stocks. So if you want to get started, what do you actually do? So I think I'm going to switch back and forth a little bit here, but as I said, this is mostly context driven this presentation. So if you go to ubm.io very intuitively, you end up on the landing page, which looks like this. Some background here. Sorry, it's all very small because I wanted to fit certain graphics onto the screen. If we go to this workflow overview, then here's this discussion of the 3 roles that I just laid out. And here you have an 8-step process. So the 8-step process is basically, I spent a couple of minutes on now how this actually works. Is first the feasibility check, which is you always see here who the parties are. So let's say you have the sustainability champion being interested in doing this type of UBM analysis, understanding what kind of retrofit packages should be applied to their local building stock. So your first step is formulating your questions, asking the GIS manager if the relevant data sets are available. And you go if you go to these different sites, you basically always see some lists and questions that it's very clear what is required. And then part of this is doing the project definition and scoping exercise. We made this little Qualtrics survey that the 3 parties can go through to basically start documenting what the process, what the idea behind the whole project is. And only then you really start getting started with the UBM itself. And so this step here, you see this is just the GIS manager. The GIS manager has to upload their data file. So usually we recommend starting with a smaller portion of the GIS model for like a seed model within the city to see if everything works, and then later expand out. But what you need to do, you import a shapefile, and then you have to assign for the different fields in the shapefile what is the building what is the building height, what is the building age, maybe any, if you know the fuel type that's being used. There's a whole bunch of information that is optional, some that is required, which is all documented here. And once basically the way this works, then once you switch from the website, you click GIS data presentation, you go, for example, here, and this is the web app. So it's pretty seamless back and forth. Once you're in the web app, you upload the GIS file, and you see here in this case, I uploaded my shape GIS file. Here I see these are the buildings that are in the model. And then here I have to assign what I said earlier, the different fields. If I'm then going to the next step, that's when the energy model takes over. So you can think about it as something where the GIS manager comes in, assigns the field, and then downloads a file from the web app that has all the information that the energy modeler needs. And then on step 4, the energy modeler uploads that file and basically starts to get going, which usually means something as what you see here on the screen. You basically see for all your different groups of buildings, for all the different archetypes, you can assign them, break them up by different age ranges, see how many buildings you have in the model, and then you are assigning basically set templates so that you can run your UBM file. Then the way this currently works is UBM.io then downloads an UMI file, which is the urban modeling interface that was developed by MIT. This is a Rhino-based plugin where you get the full file from the web app. You can just run. This is how this looks when you first download the file. You can then look at the makeup of the file, and you run an energy model. That energy model gets then fed back into the environment. I should say right now is not the ideal moment in our development cycle to give this webinar, partly because we are right now moving a lot of the simulation capabilities from having to run the simulations on their computer into the cloud. So we actually have a very fast surrogate model-based alternative to the regular Energy Plus that we are using, and that's what we currently kind of implementing. You can expect for this to be available over the summer of 2024, towards the end of the summer. And then finally, what you're doing, you're uploading, you can modify, create upgrades to your buildings in the UBM.io web app. So basically, we can look at building templates, we can apply certain upgrade packages, rerun the simulations, and that gets us to the results that are laid out earlier. So maybe one thing that might be of interest to everybody is how well does this all actually work? And I just want to share here some experience that we have collected over the last 3 years. So Oshkosh, Wisconsin was our first test case, and I should say Zach Berzola from our lab, who just graduated, pushed and organized a lot of the workshops that I'll be talking about next. So the first time in 2021, we really just wanted to we reached out to 8 cities across the world where we had contacts, a lot of them from the IBPSA community. And we wanted to contact a sustainability champion in each city. During the workshop, some MIT students and our colleagues locally did all the work for the GIS and the energy modeling. So this was more a first test to show, is GIS data at all publicly available in all these cities across the world? And how will the GIS, the sustainability champion, react to this information? Is this a valid value proposition? So then we did another workshop a year later, 2022, and there we focused on North America. And this time we wanted to basically meet our GIS managers. As I said, the sustainability champion are well established. Really, every city of any size has somebody like this. The GIS manager, it turned out we, in the city that marked here in blue, mostly, as I said, in North America, we found a lot of GIS managers as well. They actually had the title GIS manager even. And we really felt that for them, the data that we need for UberMayo and for Uber modeling in general is widely available, which is, of course, really positive because that's a key requirement. And then 1 year later, in 2023, we worked in we did a European workshop in Portugal, where we had the green cities that you see here, Rotterdam, Zagreb, Porto, Braga, and Lisbon. And there, for the first time, we also invited the energy modeler. So these were energy modelers. In some parts, there were local energy consultants. In other cases, they were actually working for the city, for one Portuguese city. They have their in-house energy modelers. So it was really nice to see that we basically here had the whole group, and we didn't have to do beyond the training much of the work at all anymore. And then just a couple of weeks ago, in January of 2024, we teamed up with the Metropolitan Area Planning Council of Massachusetts. That's a non-government, non-for-profit organization that works with over 100 communities in Massachusetts to help them decarbonize their whole economy. And we trained them how to basically use the tool. We worked with them, and they really did the analysis for all these very small places that you see here: Bristol, Natick, Reading, Everett, Somerville, Framingham, in Massachusetts. And we see this now as a way to basically push the tool out in the world. And hopefully we don't have to do much of this analysis at all anymore. So I'll spend a bit of time also talking about kind of how different the results are that we found and what is coming next. And so this figure that you see here summarizes our results for baseline, shallow, and deep retrofit for the 8 cities that I mentioned during our first workshop. And what was really interesting to see is, of course, that the results, apart from climate and building stock, also vary a lot because the interests of what municipalities want to do vary a lot. Actually, when we worked with a German city originally, there was really no appetite to electrify the heating, partly because that city also owns the local district energy system. And that, of course, changed. There's a lot more interest now in heat electrification since the war in Ukraine made access to natural gas less secure in that part of the world. So lots of different, I mean, the main point of this graph is really that you have to really carefully, you have to understand your building stock, and you have to define your use cases. And it's very important to always make sure that what you're actually modeling is of acute interest to your municipality. So far, UberMayo, in the first generation, we used it for technology pathways. So what do you do to your building stock to decarbonize it? Now we are basically moving more towards a techno-economic analysis. So who within a community is most likely to upgrade their home? And when I look at our earlier work, there we see here that we actually have a really strong built-in bias in here, because we said do you own a home? So we assumed ownership here for action because we know that is where most of the retrofitting tends to happen, especially in North America. And then who has $10,000 or $23,000 lying around? So these are some very key assumptions. So the question is, of course, which owner would pay $23,000 for an upgrade? And so for that, we recently teamed up with National Grid, which is of the gas and electric utility in New England, and worked with their surveying team to ask 1,500 households a series of questions. And what we basically found out over the survey participants is if they own the house, income, education level, concerns about emissions, number of residents. And one of the key concerns or the key inputs that really matter are if you own your house, what your income level is. Education has an effect, but your concern about the environment is really a key driver. And then we collected some information about the building itself, including its age. And we asked the real, then simple question, what is the minimum payback time that you would accept for a certain upfront cost to retrofit your home? And what we got out of this is this what we call the deal no deal line, where basically when people say, oh, I would never pay $30,000 or $40,000, that's just too expensive for me, then no matter what's gonna happen, this is probably not a valid value proposition for them. The interesting part is, of course, when somebody said, yes, I would do that, it's not clear when they would do it, but I'm gonna get to that in a little bit. But for now, if we are focusing on the deal no deal line, we created a regression model. So taking the parameters that I talked about earlier, income level, education, all the numbers marked here in orange, we take them into our regression model to predict if people would be willing to pay for an upgrade or not. And then we overlaid that with census data onto the Oshkosh data set. And then effectively what we found, which is, I think, a really positive finding, is that actually with current incentives in place, actually 70% of the building stock in Oshkosh, where a lot of people own homes, which is in the center of America, pretty common outside of the very large urban centers, that they are willing to upgrade their home, either to a really high standard, but at least to something to their building. We only found that 6% of the owners were not willing to do any upgrades. And of course, we have to focus next on the renter-occupied buildings. But overall, it was pretty positive. What you can do with the Uber models as well is you can then, of course, by census area plot where the different upgrades are going to happen. And here, when you see something in green, this is a map of Oshkosh again. In green, where the more suburbs parts of the city lie, a lot of buildings are going to be upgraded. A lot of people are going to buy electric cars. And then there are areas where income level is lower and ownership is low. So mostly tenants where not so much under current boundary conditions is going to happen. So this is an application that you can develop these type of maps out of UBM.io, where you can start telling these stories about cities. And that's, of course, really engaging for policymakers, that they, and this is where I think the true value of the UBM.io type work lies, that you can say where something's going to happen if incentive programs stay in place the way they currently are. And where do you have to focus on if you don't want to kind of have this America of two tails, where some buildings, nothing happens in certain parts of the cities and others become close to net zero. So finally, this is some really, just going to spend a couple of minutes on this so that we have time for discussion. And we can go back to the web app if there are any questions, of course, as well. So this is a graph from now to 2050 for the city of Oshkosh, what's going to happen. And what you see here, if there are no retrofits, the carbon emissions are still going to fall. The reason for that is that the grid is projected to de-electrify over time. So just by doing nothing, by having cleaner electricity, that's gonna these emissions are gonna fall. And if we are now focusing on the techno-economic potential, so here you see everybody who said, yes, I'm willing to pay if all of this happens between now and 2050. We're actually not fully at our target, but we're getting pretty low, which is great to see. Now, the biggest part is once you have this through the gate, so people are willing to pay, is how do we get people to basically act quickly? And this is where you can start looking at this technology adoption curve. I'm sure all of you have seen at one point this curve from the innovator to the laggards. Where are you within the cycle? How is the technology being adopted? The big question mark is, of course, time here. So most technologies are adopted or ideas are adopted according to a graph like this, not this diffusion curves, as diffusion curves. But the question is, where are we in the cycle? And when you look at this here, this is some, when you work from Zach, there you see if I'm following a business as usual, which is adoption of heat pump in the Pacific Northwest in the US, then we are at the very beginning. Really nothing is happening. The adoption rate is too low. And the orange curve, that's more an academic curve. If we exactly want to have full diffusion by 2050, this is what the curve would have to be. And green is really interesting because this shows you how window air conditioning units were adopted when they first came out in the US. So there are technologies that, if there is no alternative, that get adopted really quickly. And then, of course, if you use this diffusion curve and overlay to the models that I just showed you, you see that you need really quick adoption for a lot of carbon savings to happen. This happens if the adoption rate of heat pumps doesn't go up, and this is if it's more of a disruptive technology. So there's a lot to do right now. This is where we're thinking about, and this is, I think, part of the process of working with the city. How do you actually make it tenable for owners and others to upgrade their buildings? There are two ways. Either we find disruptive technology by looking at great new ways of heat pumps that are cheap to install and that look good so that people like them, want them, and put them in their home. And here you see a nice example from the gradient system. Look it up if you haven't seen it. And the other part is regulation, where basically just individual states in the US start saying everybody has to electrify their heating. So if your boiler breaks effectively, you have to get a heat pump. That works similar and would probably have a similar curve to the green curve that you're seeing down here in terms of adoption. So in closing, we can go back, and if there are any questions on the UberMyO app, we can look at them. I should say the process that is created by UberMyO has a track record. We've worked, as I showed you, with a bunch of municipalities across the world, and the information, if presented kind of in the format that I talked about, we have some example presentations on the website as well, helps municipalities to basically better understand their building stock and what would have to be done if they want to reach their goals. The way we think of UberMyO is this is, as I said, a collaborative project. So I don't think it's worthwhile to build a lot more UBM tools in the world. I think we should just focus on a few. The process is really the key thing. What we have started to do in UberMyO, just also think about it as a clearinghouse for building templates. So with the partners we've been working with, we've converted building descriptions for a building stock in a format that's easy to be read and parsed. We upload it to UberMyO. You can also download the information. And so we're always looking for new international partners to expand the library. And then in terms of if you start using the tool, probably let us know. We are actually moving right now. We're doing implementing some changes to ubem.io. One key one is that we have an online system. The idea really being is that rather than you having to upload a file and then we always start from scratch when you start a new web session, when you log in, you can keep your information of your city in there. And we've tried that online accounting system a couple of weeks ago with these different Massachusetts communities. So we're going to make that live for everybody pretty soon. And as I say, we will move the simulations towards the cloud so that you don't have to download files, run the simulations on your computer, load them up again. But these are really more processes that make the process for the energy modeler faster and easier. The big ideas here stand, and I think they stand for UBEMs anywhere in the world. So I want to leave a good amount of time for discussion. So I'm stopping here, and if there are any questions, I can also go through the web app if that's useful. Thank you.
Thank you, Christoph. That's fascinating and really exciting. I think it's really particularly interesting how this is not just a technical issue, and how much thought has been given to that, but to the social aspects of actually implementing this. It's not just working out what the numbers are that is the answer here. I would encourage everybody to put your questions into the Q&A box so that Christoph can answer them. But in the meantime, I have a couple of questions of my own. I wonder, is the main user group that you see for this municipalities, or do you see other organisations, different types of organisations, or even individuals who might be potentially using these tools or interacting with the outputs of these tools in future?
No, this is a great question. And as I said, coming from a School of Architecture and Planning, the first 5 years we were obsessed with use case 1, the new urban planning and neighborhood design. And that's a lot of fun. That's a bit like playing SimCity, where you're basically laying out a new city. You can do parametric models, you can do a million things. I think we've had a few architecture firms with whom we regularly work, our friends use the tool for this purpose. I think it's a bit of a niche application, at least where I've seen it, simply because there are not that many cities, at least in North America and Europe, being built from scratch. Sometimes it happens, and I think it's a very valid application, obviously. So that's a completely different group. And I wouldn't use I think if I look at relationships between different tools, I would probably, and we've done that in a class, use uvan.io to basically load in the GIS data, create an UMI file, and then use it for this use case 1 here. And then basically just stay in Rhino and design like we would typically do in an architecture or urban planning school. Now, at the other end of the spectrum is these are uncalibrated models, of course, meaning that we can look at trends across building templates, and if you upgrade them, what generally is going to happen. And that's what a municipality needs. They don't have access to the energy data anyhow, and it's more relief to saying, well, we should focus on installing heat pumps in the zip code. We should look at the old siding that's falling off. So that's an opportunity for adding continuous installation. I think this is the analysis that I just talked about that is ideally being performed by the municipality. This is of course a busy field. 3 is where people want to engage with portfolio owners. So people that own 100 buildings or 1,000 buildings, either distributed, if it's a chain or otherwise a real estate company, or with university campuses. I would say an key UBAM application is there. There you can start off with the same with step 2, but then you need energy data, and there's of course a growing body of research on how you auto calibrate then the energy models and basically do building by building level analysis. And finally, where I would love to be, that is kind of the buildings to grid integration, where you do a trade-off between, for a certain municipality, as we are getting to the point where in certain parts of a network, all buildings are updated and don't need the natural gas anymore. So what do we do with the 5 buildings that are left on the street that have natural gas? That's a key technology barrier, basically. I mean, so I think utilities would be well advised to look into this. Maybe in some cases that happens. So I haven't seen, I've seen interest, but not fully satisfying case study yet for this. If anybody on this here who listens to this knows of a great case study, by all means send it my way, because I think that's really where we will have to be at one point. Because even if I follow this beautiful adoption curves, that's obviously not going to work unless we start modeling at the same time the utility as well.
Thank you. It's an exciting world out there, lots of possibilities. One of the questions in the chat refers to something you mentioned you are in the process of implementing, I think, which is, do you see any potential for using machine learning to replace time-consuming and data-intensive simulation tools like Energy Plus?
Yeah, I see that. I mean, there's a current special issue that the IBPSA journal is engaged in. If you look it up, you probably see it. That is looking at opportunities for machine learning and building performance simulation. And our submission there describes a process where we kind of sped up the process of modeling using surrogate models here. So I think there's a lot of potential on. I mean, it's not going to replace the physics-based models, but I think in an Uber model, what is incredibly important that you see how accurate does my model have to be. And if I'm using this use case too, then getting monthly estimated heating and cooling loads and what changes if you do key changes is good enough.
Thank you. And now another question, which is potentially quite an exciting idea, but quite novel, which is about whether or not you could see a possibility in future of using UBEM.io to decarbonize infrastructure.
Yes, you could. I mean, certainly. I mean, there's a big push right now. I mean, everybody's aware of that we are looking at the embodied carbon of buildings as well. I mean, it seems like every larger architecture firm is working on their own tool right now. There is some really wonderful activity in getting usable data sets for embodied energy. And actually, we in our UMI tool, even 10 years ago, we had an embodied component in there. So I'm acutely aware of subscribe to, paying attention to the embodied energy as well. And there are a whole bunch of papers now out that look basically at at buildings, try to extract what's the structure. That's really the component that is missing. Like in our Uber models, typically we have embodied volumes, but we don't have the structure of the buildings. But there are some great algorithms now that, depending if it's concrete or wood or steel, basically can start pretty well guessing how much material is in that building. And so that's great for carbon accounting. I'm not sure if that question was hinting even towards bridges and so forth. I guess, sure, sky's the limit. I think for bridges, we are probably pretty good. I think with the embodied carbon, the interesting thing is really, I always find that hard to help make it actionable, because you can quantify the embodied carbon in a city, and you can be wowed by the sheer immensity of carbon that we already sunk in a city. But it's there. I mean, maybe if anything, that gives us some respect for existing cities and not bulldozing everything down and building something new. That's, I think, where this embodied argument works best. And of course, for new construction. I mean, for new construction, really the graph that I showed here, if you ever want to look at our high-level model, I simplified that here. So this would be kind of business as usual. By 2050, we have net zero buildings and we just keep on building. This basically shows you the amount of carbon that the building sector is going to use globally. It's like an estimate, which is nearly to our whole carbon budget. I mean, this is really not a good scenario. And getting all the way to net zero means that by 2030, all new construction is embodied energy neutral. And we don't even know how to do that, frankly, maybe in some fringe cases. So this is an enormous issue.
Thank you very much. Yes, it's a huge issue that is very interesting to explore. And I think the idea of using these tools for bridges as well is really interesting. We have another question now, a very important question about microclimate and how you account for that in the UBEM, given how specific the microclimate can be from case to case.
Good question. We don't. I mean, you could easily build it in by even just breaking this up into smaller seed models. If we ever wanted to, I know there's some interesting work, I think, particularly out of London, right? I know there was a study a couple of years ago where people used an enormous number of weather stations. to fine-tune their model. I think this becomes more important in areas where you don't have air conditioning. So maybe London might actually be a good case, because there are certain times when you have a microclimate, a few degrees make a real difference. In places where this is not the case, then you can put it in. I just not sure how much changes you're going to see. I think it's really always this where you can use this technology as well, this big idea of when do societies switch to air conditioning, and that is probably going to happen in a lot of parts of the world. It already is happening, and so being able to predict that is key. So there I see a benefit to the microclimate, but there are lots of ways to put how you could put that in. We just haven't done it.
Thank you. Can I ask a question now about the data that you use in these models? So is there a barrier to entry? Is there a sort of minimum amount of information that you need, which might not be available in some places? Or is it something that you can have a model more or less anywhere, but you might have slightly more uncertainty?
That's a good question when we look at if we look at these cases. So in North America, a lot of municipalities have a GIS. So what do we need? Building floor prints, building height, building age, and program. And ideally, I think in a lot of parts, you also want to know what the current fuel type is. So in Massachusetts, that's key if it's natural gas or oil that you're using. You can build a pretty decent model out of this. And of course, in North America, we have the Department of Energy building benchmark buildings and building templates. So we are really nicely set there. And in Portugal, our friends at IST in Lisbon basically build out something very similar. And the Portuguese, I guess, energy agency equivalent has created a template library that can be used that is similar, builds up the building, breaks up the building stock for Portugal. And in Dublin, our colleagues have done something very similar. They also wrote a nice paper to just showing how can use the tabular data set to use tabular data to make building template libraries. So I think this is really tedious work the first time, but again, this is where I see the value. If somebody went through the process, that we just share this, because this is really something you want to do once, defining for different residential types, what the typical R value is, what the baseline is. I think this is where the work of academia is really to make this, or government institutions to make this data available for everybody. As I said, the GIS data is really common. It is so common in North America because the tax assessor data is based on GIS. So your local municipality's income from property taxes comes from this. So these data sets tend to be pretty good, typically. If you don't have that, of course, we had some idea. I think there are a lot of kind of image recognition machine learning techniques available that you could automatically generate an UBIM input in all parts of the world, including in areas where there's no GIS data. And you could do that on a large scale. So I think this will be, there's still work to be done, but this could be made available. I think that would have to happen ideally at a country level, where somebody, maybe a country in Africa, or I don't know, different parts of the world where the GIS data is not available, initiates this project. I think from satellite data, you can get the full building footprints. You could probably get some LiDAR data to get the building heights. There's a lot of activity right now and a lot of smart people that know how to do that.
Thank you. I think that's a great application of machine learning again as well. And now another question, which is about whether or not you could see ubem.io being utilised as part of an urban digital twin platform to monitor the city in real time.
Yeah, I would say ubem.io is a quick model generator. And we're really thinking about it that way, that you can easily, we're kind of putting it together in this case for Rhino and Umi, but we are very open, and it's pretty simple to write other exporters to other environments. And then when you have an uncalibrated model, if you want it for digital twin platforms, then yeah, you can go further. You basically have to start calibrating your model, as I said earlier, and then you can feed in energy data and basically do auto fault detection and a lot of things. From our lab, Suresh Napgal has written a series of papers a couple of years ago, and they're actually doing this as a commercial activity right now in New York City.
That's fascinating. And is there anywhere in particular that we should go to find that list of publications?
Well, I mean, sure. Quickest way is if you go to our website, Sustainable Design Lab, and then to publications. God, this is slow. I think it's Zoom. Zoom is the culprit. And last name is Nak. Well, here are 4 or 5 papers, which I think they are by now 4 or 5 years old, and they talk a lot about this process.
Thank you. That looks like a fantastic resource that would be really helpful. And I wonder just finally, if you have any advice for anybody who's looking to get started in urban building energy modelling generally, but also with ubem.io in particular. Where's the best place to start? Where to look for resources to build up that skill set?
I mean, if you want to use ubem.io, we have a good amount of information, I would say, on our website. Just go through the 8 steps, get a GIS file from somewhere. You can engage your local GIS manager. So, I mean, if you do it, why don't you do it for real? Work with your local municipality. As I say, I mean, especially in Europe, when we talk to Rotterdam, they have like a completely amazing GIS data file. If you actually go to this website here, this is our step 3, I think. We call this GIS data preparation. Here, it lays out really in detail what you need. And if you show that to any GIS manager, it's very trivial for them. So get a file from them for a seed model. Then you basically, once you have that, you then go to the web app. You literally then import your GIS file here. You assign the fields, and you're off to the races. And then if you're an energy modeler, you're from the building performance simulation community, then you already know what all the assumptions in the building template are. Depending on where you are, you can use our templates, but you probably have to update your templates. The nice thing is you can just download whatever you do here, so you don't lose your work here. And if you create like a template library that you're proud of for your country, that's great. We are happy to put it up. We, as I said, work with a few groups right now. We give full accreditation whoever does this. It's a really non-fun job. So if you help others, like if you're doing it once and share, you make a lot of people happy.
Thank you. And thank you for your honesty with that about the challenges of putting together that information. And now another question from the audience. How do we estimate the accuracy of outputs from real conditions? This is one of the big challenges for urban.
That's a big challenge, and we need a lot more work on that. So in the case of Oshkosh, we got the city level building data, and we were surprisingly close. We were within 5 or 8% of the actual carbon electricity use. There's actually a paper that was published at CISPAT by Zoe Lehong that looks at the sensitivity of the Oshkosh model when you start using different template libraries. So we initially started using, for those who are from North America, there is the Pacific Northwest Laboratory kind of building template breakup that comes from NREL originally, and that they have been updating for different versions of ASHRAE 90.1. And then NREL built, of course, ComStack and ResStock, these basically US building stock-wide fantastic databases. And there they go into a lot more detail. So they have a residential building in an area from the 1940s. I think they go by decade. And what we found in that paper, that when you actually use more details, you don't necessarily get better compared to when you look at. So it's a big issue. I think as a minimum, you want to get the total emissions from the municipality for all buildings to see that you're in the right ballpark. The studies that are there, we wrote this for the IBPSA book, this book chapter years ago. We actually found by doing a literature review, a lot of times you're actually in the 10-50% range not at the building level, but at the global UBAM level, which is good. But I mean, more data, there are no two ways about it. It's important that you're making sure that what you're doing makes sense. And there's a bit of, if I want to relativize, if that word exists, that at the same time, because depending on what you're looking at, you look at relative energy differences, so that saves you a little bit. But still, I mean, being critical about what you're modeling is always key.
Absolutely. Asking questions and checking your assumptions is pretty fundamental. Yep. Thank you so much, Christoph. That's been brilliant. I've really enjoyed that conversation, and I'm sure that the audience has as well. I'm just going to finish up by letting people know what's coming next and where they can find the recording. So the next webinar in this series on urban building energy modelling tools, it will be on CitySim, and that's Jérôme Kaempf, who will be presenting on the 24th of May. A little while to wait, but you can register for that now with the QR code there. So do make sure you sign up for that. I'm sure that will be equally interesting and inspiring. Alongside this, we are running another series which is on occupant-centric simulation-aided building design based on the book which was edited by Liam O'Brien and Fahang Tamasabi. We've had a few of those already, but we've got a lot more coming up, and it's a really fascinating look at how to include occupant perspectives, how to incorporate those considerations within modelling. There's a whole series there. I share that list regularly on LinkedIn if you're in the IBPSA group, and you can find that on YouTube as well in the comments on the videos, so do sign up for those as well. So I said I would tell you where to find the recordings. Our YouTube channel is at IBPSA University. We've got recordings from the UBEM series, but also from the simulation-aided occupant-centric design series, and from all the previous series that we've had. So we're now up to about 60 videos. There's some amazing content there, a full education and building performance simulation. So do make sure to subscribe to the channel so that you're updated when new content is issued. And finally, might I encourage you to join IBPSA as a supporting member. So our supporting members pay a small fee which goes to support the work which IBPSA does, and in return they get a subscription which is either print or online to the Journal of Building Performance Simulation and the right to use the IBPSA supporting member logo. The fee has remained the same since for about 5 years now, so it's remarkably good value, and you can find out more about that at ibpsa.org/membership. So thank you very much, everybody. I hope you've enjoyed that as much as I have, and I do look forward to seeing you at another seminar soon.